Now let's practice those levels of measurement. We'll determine the ultimate measurement level for the following. Now remember, these are like ladders. Nominal is only about categories or groups. Ordinal means we can order them. Interval means that the differences between them can be measured. And ratio means that there's a true zero. So the ratio level has all of the things before it. It has differences, it has order, it has groups, and it has a true zero. The interval has differences, has order, and has groups, but no true zero. Ordinal has an order and groups, but the differences between the groups don't make sense, and there's no true zero. And then nominal, the only thing it has is that we can put it into groups. So we'll ask, can I put it in groups? Yes or no. Is there an order? Yes or no. Now, once we get a no, we're pretty much done. We don't go past that. So let's do the first one together. Hair color. Can we put hair color into groups? Sure. Brown, red, blonde, blue, black, gray, white, rainbow. We absolutely can put hair color into groups. Can we order it? No. There's not a standard order for different colors. So generally we say hair color is only nominal. But notice interval and ratio will also have no's associated with it. A zip code. Zip codes, as far as addresses go, can be grouped. They each have their own group. Can they be ordered? They could be numerically ordered. Are the differences between the zip codes meaningful? No, the differences are not meaningful. You can't say that one zip code is 3 more than another zip code. That doesn't make sense. Zip codes are codes for the post office to be able to deliver mail. So there's not a true difference between those numbers. It actually turns out that zip codes are another example of numbers that are just labels. This is another qualitative variable that's disguising itself using numbers. Automatically, if we don't have interval, we don't have ratio. So we could consider zip codes as ordinal. A letter grade. Letter grades being A, B, C, D, F. Sure, we have groups. We can order them. Is there a true difference between an A and a C, for example? Now, this is in general, not just in one class. There's not a true difference that makes sense, that can be measured. One student's C, for example, could be a 72, and another person's C could be a 76, but they all represent a C. And we could look at another student's B as 81. So the B student has 2 different measurements to get to the 2 different C students. The differences don't make sense. Plus, if you look at from class to class, if you compare a letter grade in psychology to a letter grade in English, it all depends on how the teachers have set up their grading system. So there's no true difference between the letter grades. And then also, that automatically means no ratio. So the highest level we got to is ordinal. We can order our grades, but we can't do much else than that. An ACT score, this is one of those standardized tests that some students take during high school for college entrance. They do come in numbers. They are a quantitative variable. They do indicate a measurement of a score on a test. So we do have groups and we do have order. ACT scores do have a range of numbers to them, 1 up to 36. We do have intervals. There's a difference between the numbers. But since the score starts at 1, we don't have a ratio level of measurement. We don't have a true zero here. So ACT scores are at the interval level of measurement. Heights can be grouped. They can be ordered. They have differences that are meaningful. They have a true zero. Even though we wouldn't have a person or an object with 0 height, there is a true measurement of 0 in this idea of no height. That makes sense. I can also look at this to say that if we look at the reason why it's called ratio, it's that I can form meaningful fractions. And so this idea of ratio having a true 0 means that we do get a proportional comparison, a ratio that is meaningful. And so here height would be a ratio level of measurement. Age, whether we talk about it in days, months, or years, we can put them in groups. We can order them. We do have meaningful differences. I can look at comparing myself to my sister. She is 10 years older than I am. So there's that difference there that is meaningful. And for age, does ratio make sense? So can you say that a person who is 20 years old is twice as old as a person who's 10 years old? Yes, they've lived twice as long as a person who's 10. We do have a ratio. We do have a sense of 0 for an age, newborn baby. So there is a true 0 for age. And then the last one, temperature. And we're talking degrees Fahrenheit here. We've mentioned this before. Do you remember what level temperature is? We can group them. If we were to measure temperature on different days, we could group those days into groups based on the temperature. We can order the temperature. There are meaningful differences. We can say that the temperature today is 5 degrees warmer than the temperature yesterday. So the differences matter. But there's no true 0. Remember, the 0 in degrees Fahrenheit does not mean no temperature. 10 degrees is not twice as warm as 5 degrees. So that comparison doesn't make sense. 10 degrees is 5 more than 5 degrees, but not twice as much. And so here we have interval level. Last application of our definitions. Classify each of the following variables as categorical or quantitative. Remember that qualitative with an L can also be interchanged for that word categorical. If quantitative, classify as discrete or continuous. And then determine nominal, ordinal, interval, or ratio levels of measurement. Recall that nominal and ordinal deal with categorical variables, and interval and ratio deal with quantitative variables. And we can start out with the first one, the size of t-shirts on sale. Usually t-shirts come in sizes like extra small, small, medium, large, extra large, 2X, etc. Some of them might even come smaller than extra small. Are these categories or numbers that represent counts or measures? These are categories. So we don't have to worry about discrete or continuous because it's not quantitative. Then we look at nominal, ordinal, interval, or ratio. Well, it's categorical, so we've got a choice of nominal or ordinal. We've got groups. By default, everything is at nominal level. We just have to decide if we can go further. Do we have order? Can we order the sizes of t-shirts? Sure we can. We just did. Smallest to largest, largest to smallest. We can order it. So we have ordinal level of measurement for t-shirts. The widths of doors in a home. Usually we measure widths and we get inches or centimeters. So widths are quantitative. Since they're quantitative, do we have discrete numbers or continuous numbers? Are we counting the width or are we measuring the width? We're measuring the width. So we have continuous variables. Now for the level of measure, nominal, ordinal, interval, or ratio. We automatically have nominal. We know that the widths of doors is quantitative, so we get ordinal, we can order numbers, and we get interval because the differences between the different doors would be meaningful. How about a true 0? Do we have a true 0 for width? Sure, the 0 means no width, so this is a ratio level. IQ scores reported in whole numbers of research scientists. Well, IQ scores, SAT scores, ACT scores, they're all similar in the sense of what type of data they are. There is no true zero with IQ scores. If you didn't know that, we can look it up and find that out. It actually turns out there's a whole lot of tests that are claimed to be IQ tests, but most of them range from about 40 to above 130. And IQ tests are pretty outdated. There are better ways to talk about a person's intelligence than by taking a test. So anyways, they're still floating around. So let's see if we can determine what type of data they are. Well, IQ scores are scores like a test, so they are numerical. And the numbers are a measurement or a count, so we have that. They are quantitative. It turns out that IQ scores are only given in whole numbers. So we actually don't consider them to be continuous, but discrete. And then since we don't have a true zero score, this is an interval level. So similarly to that ACT score that we talked about earlier, IQ scores fall in that same category. So would SAT scores. Any standardized test that doesn't allow for a score of 0 will fall in the interval category. How about in D, the names of television shows watched by families from across the U.S.? Do we have categories or numbers? Names of television shows? This is categorical. We can skip the discrete and continuous because categorical are neither of those. That only refers to quantitative. And now we can talk about the level of measurement. We automatically have nominal. Can we order the names of television shows in a meaningful way? Beyond basic alphabetizing, we really can't order them. Notice with the sizes of our t-shirts, we're ordering them from smallest to largest. We could look at the names of television shows, ordering them by most popular to least popular, which would not be by alphabet. So there's not this standardized ordering of them. We could look at ordering them by what station they come on or what platform they appear on. So too many ways to order prevents us from going into that ordinal level, just as no ways to order prevent us going into that ordinal level. So this is considered nominal, very much like our hair colors or our ice cream flavors. And then the last one, the yearly amount of snowfall in Cleveland over 10 years. Do we have categories or do we have numbers representing counts or measures? Amount. This is a number. So we have quantitative data. Is our quantitative discrete, meaning a count, or is it continuous, meaning a measure? Generally speaking, we measure the snowfall, so this would be continuous. And then the levels of measurement. Automatically we have nominal. We get ordinal because we can order it. We get interval because it is quantitative. Quantitative puts us in the interval level of measurement. And then we have to determine, does 0 mean no snowfall? Sure it does. So this would be ratio level of measurement. Practice as you can with these vocabulary words, applying the definitions to the different scenarios that are given. You may want to take a moment and look in the book and read through the examples that are there as well, testing yourself and then checking your answers with what's provided.